Hi, so today we're going to be doing Research Methods Part 1, How Psychologists Ask and Answer Questions. There are a lot of key concepts or vocab words we'll be talking about throughout the notes today. One of which, the first one, critical thinking, hopefully you guys have heard before. During your education, this is something teachers have probably said a lot to you guys. So what is critical thinking? Critical thinking is thinking that does not blindly accept arguments and conclusions. It examines assumptions, discerns hidden values, evaluates evidence, and assesses conclusions. Right? So you don't want to automatically just accept what people tell you. You need to think for yourself. So remember, critical thinking is something that you guys do every day. Think about the internet. I'm sure you've heard don't believe everything you read on the internet. Most articles, especially like on Facebook and social media, most of those articles actually aren't real. They're fake. They're clickbait. So you need to use your critical thinking skills to think about, is this real? Where did this data come from? Are they biased with this article? So you should be using these critical thinking skills in your everyday life, especially in school. False consensus effect. False consensus effect is when people assume that their own opinions, beliefs, preferences, values, and habits are normal and that others also think the same way that they do. An example of this is America is the best country to live in throughout the entire world. Everyone wants to live in America. So if someone thinks that and believes that, they have a false consensus effect because not everyone believes in that statement. I have traveled abroad, and especially I was in Europe, studying in Europe in 2003 when we happened to go to war with Iraq. Believe me, not everyone was saying that. In fact, a lot of people did not like Americans. But if you go to America, and depending on who you're talking to, obviously with everything going on nowadays, you'll hear a lot of people not agree with this. But you still have a lot of people that say, America's the best country. Why wouldn't you want to live here? Now think to yourself, do you know anyone like this? I believe most of us know someone who has a false consensus effect and actually do it a lot. Now, can you think of that person who, and usually there's always one main person, but there might be multiple people, who they're so surprised when people don't think the way they do, right? They always say, oh, of course, this is how everyone believes. These are people that tend to have the false consensus effect. And a lot of us might get into arguments with these people because they're so set in their ways. Oh, no, this is the way it is. This is what everyone believes, even though obviously that is not the case. Hindsight bias. Hindsight bias is a word you guys might have heard before, and it is a word that you'll be using throughout the year. You'll notice this in psychology we've talked about and we'll talk about all year. These are things and terms you use in your everyday life. Hindsight bias is one that you guys will repeat throughout the year, I guarantee. So what is it? Hindsight bias is the tendency to believe after learning in an outcome, that's the key word, after right there, that one would have foreseen it all along. This is also known as the I knew it all along. After, that's the key word. So you change your opinion or you knew something after you learn the outcome of it. So for example, let's say I like to watch sports. And let's say on Monday I get to class and I'm like, oh, I knew this team was going to win. Well, if I knew that team was going to win, why didn't I say that on Friday? Why didn't I pick that team to win in my fantasy pool? Right? So if I knew something afterwards, that's hindsight bias. Once again, think about a personal example. When have you used this before? Do you know someone who does this a lot? There are some good videos on hindsight bias. I will try to post them underneath these sets of notes on the YouTube channel. So what I want you to do right now, in your notes, scrap piece of paper, doesn't really matter. There are 6 statements here. All right, so I want you to read the 6 statements and then just write true or false for each one. All right, or you can just write T for true, F for false. So as you're watching the video right now, pause the video so it doesn't go on to the next slide, because I'll move on. It'll take you a little bit longer to actually answer the questions. All right, so pause the video right now, read each statement, and then just mark true or false. All right, now that you have answered all the questions, hopefully you paused the video and you've moved on. Now here are the answers. Let's see if your answers matched up with what you had. All right. As you go through this, and any of your answers were wrong, and you said, "Oh, I knew it was really true," or "I knew it was really false," that was just an example of hindsight bias. So now obviously, if we were in a classroom right now and doing this, usually there's always 1 or 2 students who say that out loud, and then that's a perfect example of hindsight bias, right? If you knew the answer the whole time, if you knew it was true, or if you knew it was false, why didn't you say that in the first place? All right, so that is hindsight bias. All right, so now we're going to start talking about experiments, the different parts of an experiment. One of the key things to know about an experiment is it's the only way to describe cause and effect. All right, so we're going to talk about experiments and correlation later on. Key thing to know for experiments, it's the only way to describe cause and effect. So how do we do experiments? Right, we use the scientific method to guide our research. This is something that you should have heard since elementary school, right? Pretty much every science class you've taken, you've always heard the scientific method. On the next slide, I'll do an outline, go into more details about the process of an experiment. You can see the little diagram right there, about observations, the hypothesis, which is the educated guess. You come up with predictions, you test these predictions. If your results aren't consistent, then maybe you relook at your hypothesis. If they are consistent, then eventually, you'll develop a theory. Obviously, that's far down the line, but that's the overall idea of the scientific method. All right, so the scientific method, this is just a basic outline of what it is. Some of these I will go into more depth on the slides to come. So maybe if you wanted to look ahead and see which one, so you can leave some space for your notes. So first, what you want to do for the scientific method is you want to develop a theory, right? And these are based off your observations. So you observe something, and then you start to develop a theory based off those observations. But you don't know if that's true or not. So then what you must do, you must create a hypothesis, right? Which is a testable prediction, right? You're making an educated guess about something. Then you have to pick your population, right? So who are you going to test? Then you must randomly sample from that population, and then you must randomly then you have random selection as well, and then you randomly assign, which I'll talk about later, that population, that random sample, into one group or the other, the control group or the experimental group. A key thing that you must do during experiments is create a clear operational definition. This is where a lot of experiments fall short when people are actually doing experiments. We'll have some homework on this later on. So an operational definition, make sure you understand this, is a statement of procedures used to define research variables. So what does that actually mean, right? It's how you're going to measure something, right? A clear way of measuring something. So an example, if you're measuring how hardworking someone is, you could define it as overall GPA. right? So if you want to do a test on how smart someone is or how hardworking it is, well, that's very subjective. So how do you actually measure that? You need to come up with an operational definition. If I want to do an experiment and see who's the smartest, well, how am I going to measure that? I need something I can actually count. So I could do GPA, I could do test scores, things like that. If I want to do an experiment with how sad people are, well, once again, that's very subjective. How am I going to measure that? I need to create an operational definition for how sad people are. It could be how many times they cry or something like that. Same thing with how happy they are. Well, that's very subjective once again. So I need to create an operational definition for something they can measure. So maybe how many times they smile, how many times they laugh, right? That is creating an operational definition. After that, another important part of the scientific method is to identify what your independent and dependent variables are. We'll go into more depth on that on the next slides to come. Other things you must do is look for extraneous or confounding variables, which we'll go into more depth again. You need to decide what type of experiment is it going to be. We have double-blind experiments, we have blind experiments, and so on. After you do the experiment, you need to gather the data, right? This is your raw data. And then you need to analyze the data, right? So you have all these numbers in front of you, but what does that actually mean? All right, so analyze the data. And then there's a video I will be posting on the scientific method, a humorous one. All right, so the variables. All right, so the two main variables of an experiment. You have the independent variable, which is the manipulated variable given to the experimental group. And then you have the dependent variable, which is used to measure the effects of the independent variable, right? It measures both the experimental and the control group. So you have two groups. You have the control group, which doesn't get the independent variable, right? That's what you pretty much, depending on what you're testing, they're getting the status quo. Then you have the experimental group. They are getting you have the experimental group, which is getting the independent variable. The dependent variable is, the key word to that is, it is what you measure, all right? So that is key to the dependent variable. It is what you are measuring, right? And you measure the same thing for both the control group and the experimental group. So like, let's say I wanted to do an experiment on, are these new brakes better for like my car or my bike, right? So my dependent variable would be, how long does it take you to brake, right? So the control group might get the old brakes, right? Because we pretty much know what those are, right? You get new old brakes, the same brand or whatever it might be. The experimental group would be the new brakes. And then I'm going to do the same experiment, the same procedures for both sets of brakes, and then I'm going to measure both groups to see how long it takes them to stop. That would be my dependent variable. Key thing for dependent variable, it is what you are measuring. All right, independent variable is what you're manipulating, so pretty much that's what you're testing out. All right, so the experimentation. What you want to do is take a random sample to locate your participants, right? So if you already have your population, right? So let's say you want to do an experiment about Thornton High School, right? So Thornton High School would be your population. Then you want to randomly sample students as your participants. And I'll go into more depth on that on the next slide. All right, so these are different types of experiments. Right? You have blind experiments and double-blind experiments. A blind experiment is where only one person doesn't know what they have. Right? So when you do an experiment, let's say you're testing like a type of drug, like a new type of painkiller. Well, half the people are going to get the new painkiller, and half the people are going to get something called a placebo, which is like a sugar pill. In a blind experiment, let's say the participant doesn't know what they're getting, but the researcher or the doctor does. A double blind is the best experiment you could do because neither the researcher nor the participants know what group they're in, right? They don't know whether they're control group or experimental group. That's very important. Why is that important? It's because you want to avoid the placebo effect, right? Placebo effect is where experimental results are caused by expectations alone. Like if you thought you were taking the aspirin, so your headache went away, even though you were just taking a sugar pill. So a lot of times placebo effect is where you think you're getting medication to help you, so then you naturally start to feel better. There's lots of examples of this. I'll post a video from Freaks and Geeks where in the video, and maybe you guys have seen this, is they replaced a keg of beer with non-alcoholic beer at a party. Well, they were drinking what they thought was beer, so you see these people going around acting like they're drunk when really they weren't drinking alcohol at all, right? That would be the placebo effect. The other reason why we do a double-blind experiment is to avoid experimenter bias, right? And experimenter bias is favoritism towards a result expected by the human experimenter. So if it's just a blind experiment and the doctor knew which pill you're getting, whether the sugar pill or the medicine, they might treat you differently. And they might not do it on purpose, but if they knew you had the medication, maybe their mannerisms and what they say to you, like they expect you to get better. Or if they knew you had the sugar pill, right? Maybe they don't expect you to get better, and you can see that through their body language and certain things that they say to you. So that is why double blind is best, is to avoid the placebo effect and to avoid experimenter bias. As you notice throughout the notes, certain words are bolded. Obviously, those are vocab words, right, that you should know. Now, random sampling, going into a little bit more detail on random sampling, which I'll post a short little video on this as well, right? Random sample is where every person has an equal chance of being chosen to participate. Random assignment is randomly assigning a person from your sample to one condition or another, right? To either the control group or the experimental group. So a lot of people get these confused because obviously you have random in both words. So let's say once again we're doing an experiment in Thornton, right? Thornton Township High School. The students are our population. Well, I can't sample all 2,000 students at the high school. So I need to randomly sample from there, right? And make it random, it has to, encompass all students, right? So if I want to do the whole high school, I need freshmen, sophomores, juniors, and seniors. I need girls and boys. I need students from lower level classes, regular classes, higher level classes to really encompass the entire school. That's random sample. So now, we got 2,000. I randomly choose, let's say 100 students from Thornton to take part in my experiment. Now I must randomly assign those 100 students into either the control group. So I have 50 going to the control group and I have 50 going to the experimental group, right? So I'm randomly assigning that. So random sample is randomly choosing which students you are going to participate in your study, in your experiment, from the overall population of whatever it might be. And a random assignment is actually putting those either into one group or the other, the control group or the experimental group. All right, so during the experimentation, you create the experimental group, like I just said. That gets the independent variable, and then you create the control group, right? So we talked about where you randomly assign to one or the other, right? Use random assignment to put people into the two groups. Obviously, that's a very important part of the experiment. All right, so during the experiment, you're using the dependent variable to check to see if your independent variable caused your desired results, right? So you do the experiment, you measure both groups, and then you see what the results were. Obviously, for the best results, you want to replicate the study, right? If you just do a study one time, well, maybe something went wrong, right? We don't know what happened, so maybe your results weren't accurate. So you need to replicate the study numerous times, depending on what you're talking about. It might be a few times, it might be hundreds of times to get the best results. We're going to break down the scientific experiment later on. We're going to do you're going to have a quiz on it, and during that quiz, that's something you're going to be looking at in your homework and during that quiz. The other thing you need to do is you check for extraneous or confounding variables. It means the same thing. You need to know both because you never know which one you're going to see. So extraneous or confounding variables, these are factors that affect the dependent variable but aren't the independent variable. So what that means is these are things that are going to affect the data, the measurements that you're taking from both groups. It's going to affect the results, but you didn't mean for it to affect the results. So you're not getting accurate results in your experiment. So let's say you're doing an experiment outside. Well, you do it over multiple days, but the weather was different each day. And that could affect your results. That could be an extraneous or a confounding variable. All right, that's why you want to limit as many variables as possible when you're doing it. You want to try to keep everything exactly the same except for that independent variable. Right? The better you can do that, the better your results will be for your experiment. Ethics. All right, so it's very important to follow the ethical guidelines when you do an experiment. There are 4 main principles developed by the APA that must be followed. The APA is the American Psychological Association. You've probably heard of it before. It's also a way you can cite your papers. So the 4 things they came up with is to obtain the informed consent of potential participants. The second thing is to protect them from harm or discomfort. The third one is to treat information about individual participants confidentially. Right? You can't be giving out names of people you do experiments on. And the fourth thing, you must fully explain the research afterwards. So we're going to talk about a number of experiments this year, especially towards the end of the year, and you'll see a lot of the experiments that were done, we couldn't do again because they don't follow the ethical principles. So there's one called the Stanford Prison Experiment, which we'll talk about. They had to end early because kind of breaks number 2, protect them from harm or discomfort. You're going to see there were some people, they had prison guards and prisoners in a fake prison, but they had to end it early because the prison guards were harming the prisoners mentally. There's the Milgram shock experiment, which kind of does the same thing. Once again, probably there was ethical issues with that one. Probably couldn't be done again. There's been famous ones throughout history that have been known to be extremely unethical, like I believe it was the Tuskegee experiment, where they unwillingly gave African American males syphilis. So if you go through those 4 ethical conditions, that breaks all of them. Obtain informed consent. They didn't know they were getting it. Protect them from harm or discomfort. It's an STD. You can die from that. Henry VIII died from that. If you remember him from history, he's the one with the 6 wives. Treat information about participants confidentially. Not real sure on that. I think they probably published it, or the names might have got out. I'm not sure about that one. But number 4, fully explain the research afterwards. They didn't know they had it. They never explained it afterwards. Sometimes you have to you can't tell the participants everything that's going on in your experiment because that might influence the way they act and influence your results. But then you have to explain what happened afterwards. All right, so we're going to talk about different types of research. You can list them here. Leave space because I'll go in and talk about each one afterwards. And we'll talk about correlation. That will be research part 2. We'll talk about correlation. So the first type of research is descriptive research. So that could be a case study, it could be a survey, or it could be naturalistic observation. Correlation, we'll talk about later. And then experiments, we've already talked about. All right, so what is a case study? A case study is an intensive examination of an individual hoping to discover a generalization. Often it can be used as a stepping stone for more research. A lot of times we use this in unusual cases to provide insight to concepts we otherwise wouldn't be able to understand. Example of this would be like multiple personality disorder, which is actually called DID, dissociative identity disorder, but that's when someone has multiple personalities, like the movie Split, if you've seen that. So key thing about case study, right? It's an intensive study into an individual or a small group of people, right? And there's two main reasons why, right? So number one is, well, we don't know if we want to put a ton of money into like a big research where you're researching, maybe you have like thousands of participants. So you do a small group and see what the results are. And if the results are favorable, right? So you do the case study on the small group. And then if the results are favorable, now you'll invest a lot of money into a big research experiment. The other reason you do a case study is because there's just not a lot of people to study, right? So if it's something rare, like someone with DID, which is multiple personality disorder, so you do a case study on them because you can't find thousands of people with that. And there's lots of different scenarios with that, like Jeannie, which is someone we'll talk about, who was a feral child, right? Those are very rare people, so you can't do a big experiment on that. So it would have to be a case study. Next thing we'll talk about surveys. This is something you guys should be familiar with. A lot of you guys have probably already taken surveys before, or a lot of you guys might have even developed surveys. I know the stats class used to develop surveys and they used to have to give them to the different classes. So what is a survey? It's a technique that uses predetermined questions for people to self-report. Their best results come from a random sample. So when my former students would give their survey out, if they only gave it out to people in their own classes or to their friends, the results probably weren't the best, because if you gave it to your friends, a lot of times you're friends with people who think similar to you. All right, so they're going to have similar results. Or if you just gave it to people in your classes, let's say you're in all honors classes, well, now those people are probably going to think similar to you as well. So when you do a survey, you want to randomly, give it out to multiple different people who think differently. All right, so I've done surveys in the past, sometimes even ones you get paid for, and I have to kind of put in my information because they want to get the opinions of a wide range of people, not just one particular group. All right, so you want to make sure your sample of who takes the surveys is random. So why do we sample? One of the reasons is the false consensus effect, which we've already talked about at the beginning. If you remember from the beginning of the notes, the false consensus effect is the tendency to overestimate the extent to which others share our beliefs and behavior. So why do we sample? Because not everyone thinks the way we do. So we need a random sample. We can't have that false consensus effect where we think everyone thinks the same way we do, right? It's just like the surveys I was just talking about. We can't assume everyone's going to think like me and my friends do. You must get that random sample because everyone thinks differently. Sometimes it's hard to think that, oh, you actually think this way, but people do think that way. So you need to randomly sample and get the opinions of everyone. All right, the last slide for research part 1 is naturalistic observation. So what naturalistic observation is, gathering information about people or animals in their natural surroundings. It doesn't explain behaviors, it only describes them. That's key, right? So you're not saying why they're doing something, you're just describing what they're doing. So if you remember, like Jane Goodall, if you've heard of her, she spent decades in, I believe, studying gorillas, right? So she was just studying them, kind of lived with them almost, and would just write down and describe the behaviors of them in their natural habitat. And then we've learned a lot about them because of that. Like they, use tools, simple tools, but they use tools, how their family was made up, how they cared for each other, right? And we also do that for humans, where we might observe them in their natural habitat. A lot of times we'll do this for babies, right? We'll put them in a room with different toys, different people, and see how they react, right? That would be a naturalistic observation.